A biprism is placed at distance of 5 centimeter. A biprism is placed at distance of 5 centimeter in front of narrow slit illuminated by sodium light of wavelength 5890 angstrom, and the distance between virtual sources is found to be 0.05 centimeter. The width of fringes observed at a distance of 75 centimeter from the biprism, 75 from the biprism, that means total distance will be 75 plus 5, 80 from the slit. Fringe width will be how much? So distance between slit and biprism 5, biprism and screen or eyepiece 75, total distance 80. So fringe width is lambda d by d, that will become 5, 8, 9, 0, 10 raised to minus 10 into distance between slit and eyepiece, total is 80 centimeter, convert into meter. Small d is 5 into 10 raised to minus 4. 5 into 1 is 5. Remainder, this is 8. 5 into 1 is again 5. Remainder 3, 39. 5 into 7, 35, 4. 5 into 8 is 40. So 1178. 5 into 1, 75, 30. Remainder is 4, correct. Into 8 into 10 raised to minus 12. That is minus 11 plus 4. 8 into 8, 64. Carry 6. 8 into 7, 56. And 6. 56 and 6, 62. Carry 6. 8 into 1 is 8. 8 and 6, 15. 8 and 6, 14. Carry 1. So 9424 into 10 raised to minus 7 in meter. Let me check the option. 9424 is everywhere. Converting this in millimeter. So it will be into 10 raised to minus 7 meter given, no. That is same as 10 raised to minus 5 centimeter we can write. 9424, 10 raised to minus 5 centimeter option. So only calculative error possible in this sum. Sum was easy, right?
Done, sir.
Okay. Sum number 43. The refracting angle of biprism. See, biprism is two triangular prism connected base to base. This is called biprism. And this angle is called as refracting angle of the prism. So refracting angle is of the order of 0.5 degree, and vertex angle, this is of the order of 179. So refracting angle of biprism is C, option C, 0.5. You have to remember this, huh? This is called vertex angle. So vertex angle is nearly 179, and this refracting angle is 0.5, 44. Many of you might not have got this answer. In a biprism experiment, micrometer reading for 0 order and 10th order, 0th order and 10th order are 1.25 millimeter and 2.37 millimeter respectively. When light of wavelength 6000 angstrom is used, if the light of wavelength 7000 angstrom is used, then what is micrometer reading for 0th order and 10th order? This is the case. First, see, question is, when I use this wavelength 6000, I get 0th order means central bright at 1.25, 10th bright at 2.37. This central bright, does it changes the position?
No, sir.
No. So can I say even for second wavelength, my central bright will be at 1.25 millimeter only? Now I have to find 10th bright. What is formula for nth bright? Is it n lambda d by d? Correct.
Yes,
N. So that means 10th bright minus 0th bright of first color upon 10th bright minus 0th bright of second color is distance between center and nth bright. This is the meaning of this. Will be equals to lambda 1 upon lambda 2. So x10 is 2.37 minus x0 is 1.25 upon दूसरा वाला x10 we want minus 1.25 is same for both. Lambda 1 is 6000 and lambda 2 is 7000. So in fact 3 zeros will get cancelled. That means x10 of second color minus 1.25 will be 7 upon 6 into difference is का 7 minus 5 2, 3 minus 2 1, 1.12. Cancel होगा क्या देखता हूँ जरा. 6 into 1 is 6. Remainder will be 52. Okay, not perfectly divisible. थोड़ा तो cancel कर सकते हैं. 6 into 0.6 into 1 is 6. Remainder 5. 6 8s are roughly 48. So x10 for second color is 1.25 plus 7 8s are 56. 7 and 5 12. So this will be close to 6 and 5 1 5 2. So 2.51 and 1.25. So I can say 7 and 50 is 5, 7 and 5 12. Therefore it will be 6 and 5 11, 2 4 5. Close to option A. Close to option A is the required answer. Once done, then say, please.
Done, sir.
Sum number 45. In double slit experiment, fringes are formed using light of wavelength 4800 angstrom unit. One slit is covered with thin glass film of refractive index 1.4 and another slit is covered film of same thickness but of refractive index 1.7. By doing so, the fringe width is shifted to the fifth bright band. Shift is to the fifth bright. In the original path, by doing central shifted to this, then thickness will be, thickness is not printed, thickness will be shift in number of fringes is given by formula mu minus 1 into T by lambda if there is only one. Shift in number of fringes is mu minus 1 into T by lambda when only one path is covered with the thickness. When there are two films placed, so it will be mu2 minus mu1 into T by lambda. ये formula आपको by heart मारना है. Now shift is fifth bright, mu2 is 1.7, mu1 is 1.4, thickness is T. Upon lambda 4800, I am converting in meter, 4.8 into 10 raised to minus 7. So 5 equals to 0.3 into T upon 4.8 into 10 raised to minus 7. So T will become 5 into 4.8 into 10 raised to minus 7 upon 0.3. 3 into 16 is 48. 16 into 5 is 80 into 10 raised to minus 7 meter. So T will be 80 into 10 raised to minus 4 millimeter. That means 8 millimeter is thickness of that sheet, which is placed in the path of both the interfering beam. 8 into 10 raised to 4.8 into 10 raised to minus 7 meter. That means 10 raised to minus 4 millimeter. 8 into 10 raised to minus 3. 8 into, finally I am writing, 8 into 10 raised to minus 3 millimeter. That is option 3. So formula for shift in the fringes, when in the path of one of the light we place the material of refractive index mu is mu minus 1 into T by lambda. Yes, done.
Yes, sir.
46. The central fringe of the interference pattern produced by light of wavelength 6000 Armstrong unit is found to be shifted to the position of fourth bright. After glass plate of refractive index 1.5 is introduced, then thickness of that glass plate is how much? So that formula now, n is mu minus 1 into T by lambda. N is 4, mu is 1.5 minus 1. T we have to find lambda 6 into 10 raised to minus 7. So 6 into 4, 24 into 10 raised to minus 7 upon 0.5. Therefore, T is 24 upon half into 10 raised to minus 7. So T is 48 into 10 raised to minus 7 into 10 raised to plus 3 millimeter. Therefore, T is 10 raised to, answer is given all in micrometer. So we can say 10 raised to plus 6 micrometer, 4.8 micrometer. This formula you have to remember. Derivation you have not done in 12th. But once I start explaining you polarization, that is tomorrow, then I will explain even this two part.
Done, sir.
47th. If light of wavelength 6328 Armstrong. Hello? Hello? Yeah? नहीं मुझे इंटरेस्ट नहीं. If light of wavelength 6328 Armstrong is incident on a slit width of 0.2 millimeter, perpendicular then angular width of central maximum. Angular width of central maximum. See, on one slit, then it is called diffraction. Incident on a slit, not double slit, that is called diffraction. What is diffraction? If this is one opaque body, and here we have source of light, emitting light in all direction. So because of this opaque body, there will be shadow produced here. If there is an opening, and here is source of light, then this will be light, and upper part will be geometrical shadows. So when the source of light is obstructed by opaque body, or it is passing through a slit, then at the ends it shows the property of bending. So bending of rays at the edges, which will illuminate geometrical shadow, is called as diffraction. Bending of rays at the edges, which can illuminate geometrical shadow, is called as diffraction. Geometrical shadow is called as diffraction. Now they are telling, so what is angular width of central maxima in diffraction? So in diffraction, width of, see, diffraction word is not given, but single slit or single opening is diffraction. Double slit is interference if not given clearly. So in diffraction, width of central maxima comma beta equals to 2 lambda d by t. So angular width is beta upon capital D. Beta is 2 lambda d by d upon capital D. I can cancel this d by d. So theta will become, answer will come in radian, but if option is given in degree, then you have to convert radian to degree by multiplying with 180 upon pi. So this will be 2 lambda 6328 into 10 raised to minus 10 meter upon 2 into 10 raised to minus 4 meter. 2 to cancel. So theta equal to 6.328 into 10 raised to minus 6 radian. But in answer I can see it is given in degree. So this is nothing but 180 upon pi in degree. Pi is 3.14 roughly. I can assume this is 6.28 को cancel कर सकते हैं roughly approximate. So 360 into 10 raised to minus 6 in degree. देखते हैं अभी ऑप्शन क्या लिखा है, डिग्री है क्या, मिनट है क्या, सेकंड है. ऑप्शन is in decimal. 10 raised to, this was 6328. एक मिनट है, इधर मिस्टेक हो गया. When I take 6.328, then it will be minus 7. So minus 7 and this will become minus 3. Minus 3. This is also minus 3, minus 3. So final answer 0.36 degree will be the required answer. That is given as option A. Right. See, diffraction word was not given, but single slit means diffraction. And after completing, right, bending of rays at the edges, which can illuminate geometrical shadow, is called as diffraction. Done. Yes, completed. Hello, completed.
Yes, sir.
Next one is same theory which I discussed. Bending of beam of light around the corners of obstacle is called as diffraction. That is option B. Option B. 50th. A single slit of width. Single slit of width. Single slit आया मतलब diffraction है, याद रखना ये. 0.20 is illuminated with light of wavelength 500 nanometer. The observing screen is placed at 80 centimeter from the slit. That is capital D. Width of central maxima will be width of central maxima in diffraction. Width of central maxima in diffraction is beta equals to twice lambda divided D. So 2 times lambda 500 nanometer is 10 raised to minus 9 meter. Capital D 80 centimeter into 10 raised to minus 2 in meter. 0.2 millimeter, so 2 into 10 raised to minus 4 meter. You can cancel this. 5 into 8 is 40 and that 3 zeros 10 raised to 3 into 10 raised to minus 11, 10 raised to plus 4 will come up. So beta equals to 4 and 3 7, 7 and 1 8 into 10 raised to minus 11. So it is 4 into 10 raised to minus 3 meter, which is 4 millimeter. Let us check 4 millimeter. 4 millimeter, yes, options. 4. Should I clear this? Hello, here.
Yes, sir.
Next 51. The first secondary maxima condition for minima in diffraction is path difference d sine theta equals to n lambda, where n equals to 1 to dot dot dot. For maxima, उल्टा आ रहा है ये, path difference d sine theta is 2n plus 1 lambda by 2, where n is 1 to dot dot dot. So for maxima it is like minima in interference, and for minima it is like maxima in interference. But we have written 2n plus 1 because here first maxima will come when path difference is 3 lambda by 2 after central maxima. So which is the condition for first maxima? First maxima means n equal to 1. So d sine theta will be 3 lambda by 2 for first maxima. 3 lambda by 2 is option D. They have taken distance as A, I have taken as T. So option D is the correct one. Completed this also? Yes, completed. 51.
Yes, sir.
52. Diffraction and interference of light suggest. Diffraction and interference suggest what? Nature of light in electromagnetic wave. Hello? Nature of light is transverse. ये कौन बताता है? Polarization. और interference diffraction shows the wave nature. B वाला. Wave nature is shown by interference and diffraction. Transverse nature is by polarization, and quantum nature is by photoelectric effect or radiation. So this is B. Wave nature is interference and diffraction. Wave nature means crest meeting, trough meeting. Quantum nature means energy is h nu. Next, a single slit width A, मतलब D को A दिया है, is illuminated by violet light of wavelength 400 nanometer, and width of diffraction pattern is Y. When half of the slit width is covered, that means new slit width is A by 2, the first one, the second one. And then it is illuminated by yellow light of wavelength 600 nanometer. Then width will be how much? Central maxima is 2 lambda d by d. First upon second will be lambda 1 upon lambda 2 d2 by d1. So y upon beta 2, lambda 1 400, lambda 2 600, D2 is A by 2 and D1 is A. A cancel, 0 cancel, 2 into 2, 4, 2 into 3, 6. So new fringe width is 3 times first. Yes, completed 53.
Yes, sir.
54. The main difference in the phenomenon of interference and diffraction is, say, interference is due to two coherent sources obtained from single. So diffraction is due to interference light from different part of same wavefront बराबर है, but interference is interaction from two isolated wrong. So first is not the answer. Diffraction is due to interference different part of same wavefront, right? Whereas interference is the interaction of two wave derived from the same source. Yes, B is correct. Diffraction is due to waves obtained from single wavefront and interference is two waves obtained from single source. Therefore, option B. 55. If the first dark line जी कोई नहीं है अच्छा सामने कोई दिख रहा है आपको हाँ एग्जैक्टली ऑपोजिट कोई दिख रहा है हाँ जरा उनका नाम देखो वो बंदे को फोन दो ना 1 मिनट मैं बात करता हूँ हाँ नहीं क्लासरूम नहीं एग्जैक्टली सामने जेरोक्स की हेलो ये क्रिश बोल रहे हैं ना हाँ ऋतिक ये सर ना आपको फीस देंगे तो आप रख लो तो संतोष आएगा तो दे देना या तो फिर मैं शाम को आऊंगा तो मैं आपसे कलेक्ट कर लूंगा या संतोष आएगा तो फोन करने बोलना उसको क्योंकि है नहीं संतोष ना बात अच्छा अब अभी इनको दीजिए ना फोन मैं बात कर लेता हूँ हेलो सर कितना दे रहे हैं आप उनको फीस 25 ना दे दीजिए उनसे मैं बात कर लिया तो मैं उनसे कलेक्ट कर लूंगा नहीं कुछ नहीं वो एक्चुअली क्या मेरा ऑफिस वाला वो बैंक गया है मैं आपको उसका कंफर्मेशन भेज दूंगा अभी 5 मिनट में सर यस नो प्रॉब्लम थैंक यू हाँ आर्यन उन्होंने पता है हाँ थैंक यू Hello? See, if the first dark line is to be formed at 1 degree with light of wavelength 5000, then width of slit will be how much? And 1 degree का value दिया है. So first dark means sine theta, d sine theta is 1 lambda. We want to find d. This is sine of 1 degree. Lambda is given as 5000 angstrom. So 5 into 10 raised to minus 7. This is 0.0175 is 5 into 10 raised to minus 7. Therefore, d will become 5 into 10 raised to minus 7 upon 175 into 10 raised to minus 4. 5 into 3 is 15. Remember 2. 15 divided to 5 5s are 25. So d will become 10 raised to minus 3 upon 35, which we can write as 100 or 1 upon 35. 10 raised to minus 3. This is in meter, will become millimeter. So I can say 100 upon 35 into 10 raised to minus 2 millimeter. This is close to 3 into 10 raised to minus 2. So close to 0.03 millimeter. Let us check. Close to 0.03 millimeter. 0.0303. Which one should I take? 3, 4 चलेगा क्या? Close to 0.03. C should be taken. See, if you see carefully, C. Is it?
Yes, sir.
When
Yes.
you round off, it will become 0.03. So this is the answer. So in fact, diffraction part is very simple. खाली वो formula याद रखना. Completed? Or shall I clear this now? Yes, completed.
Yes, sir.
Yes, sir.
Okay,
Yes,
please
sir.
tell faster once you complete. Otherwise, I cannot see you. No? On increasing the slit width, what will happen? Width of central maxima. Width of central maxima in diffraction is twice lambda d by d. So when you increase slit width, that means d is increased, then fringe width will decrease. So it will decrease. Option C. '57. A slit of width A is placed in front of focal length 0.5 meter. Focal length is approximately distance between slit and screen. Like this is convex lens, this is slit, this is eye screen. So from convex lens, when the ray passes, it will meet at this screen. So this capital D and focal length, ये focal length है, और इधर से इधर capital D, both are taken same in case of diffraction. It is illuminated by light of wavelength 5.89 into 10 raised to minus 7 meter. The first diffraction minima on either side of central maxima are separated by 2 into 10 raised to minus 3. Then find width A. First minima, ये center, इधर से start होता है first minima. ये first minima. So distance between first minima is actually width of central maxima. So minima on either side are separated by 2 into 10 raised to minus 3 meter. That is nothing but this distance, width of central. So width of central is distance between minima on either side. Find the width of slit, that is D, we have to calculate. So same, beta is twice of lambda, d by d formula. Beta is twice lambda d by d. So small d will become twice lambda, capital D upon beta. 2 into 5.89 into 10 raised to minus 7, capital D 0.5 meter, and beta is 2 into 10 raised to minus 3, 2 cancel. So D will become 0.5, 5 into 9, 45, 5 8s are 40, so 44 carry 4, 29 after 3 digit decimal into 10 raised to minus 4 meter, which is same as 2.943 into 10 raised to minus 1 millimeter. The option A मीटर में दिया है. Once you complete, say properly.
Done, sir.
If there is circular opening in an opaque sheet, then on the screen alternate bright and dark lines are observed. No diffraction, one circular spot, circular pattern is observed. That means this is suppose opaque body. Here there is small hole, here there is a screen. So light इधर आएगा, ये सब shadow को ये circle दिखेगा ना इधर, बाकी सब shadow को illuminate करेगा, मतलब circular ring जैसा दिखेगा. So option D, circular pattern will be formed. That means geometrical shadow will be slightly illuminated. Hello? Hello?
Yes, sir.
See, this is shadow. Shadow. Due to diffraction, there will be illumination alternately, bright dark, bright dark. So ये circle इसलिए गोल 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 दिखेगा. So circular rings will be obtained. Pattern is observed due to diffraction. 59. I have already given you formula for limit of resolution for microscope as well as telescope in ray optics chapter, instrument wale mein. Have I given you or not?
No, sir.
No, I think I've given. चलो फिर से एक बार लिख लेते हैं. For telescope, if I done the sum I told you यही वाला इस बार एग्जाम में आया था. वो अपना 203 जो शीट है ना 303 वाला पहले वाला उतना फिर से देखो. Minimum angular separation for telescope when object appears separated is given by theta equals to, this is called limit of resolution. Limit of resolution. देखो मैं बोला था एक जाली अगर है विंडो पे, दूर से देखा तो हम लोग को ये पूरा फिल्म लगता है, सामने आ गया तो जाली जाली दिखता है ना. तो ये दो जाली के बीच में कितना डिस्टेंस सो दैट वो सेपरेट दिखेगा या कितना एंगल सबटेंड करेगा उसको हम बोलते हैं लिमिट ऑफ रिजोल्यूशन. सो लिमिट ऑफ रिजोल्यूशन मींस मिनिमम एंगुलर सेपरेशन so that object is seen clearly. For telescope is theta equal to 1 point d lambda upon d, d equals to diameter of lens used, diameter of lens, and resolution power is reciprocal, which will be d upon 1.22 upon lambda. And for microscope, limit of resolution is minimum distance denoted by d, which is 1.22 lambda upon 2 mu sine theta for self-luminous body like star, jellyfish, और जहाँ पे आप लाइट इंसिडेंट करने वाले वो खाली लैम्डा अपॉन 2 mu sin theta. And resolution power is reciprocal, so either 2 mu sin theta upon 1.22 d upon lambda or resolution power 2 mu sin theta upon lambda. So resolution power is reciprocal of wavelength. Mu sin theta is called as numerical aperture. Right. Write the formula. With formula, we'll get answer directly. Part is easier one. Just write formula. In tomorrow's lecture, I will complete this and explain you the concept of polarization, which was a few homework problem in wave theory of light.
सर स्मॉल डी क्या है यहाँ पे?
Small d is the minimum distance between two objects. Theta is minimum angular separation. देखो एकदम दूर ऑब्जेक्ट हो तो पॉइंट दिखता है ना, तो उसका डिस्टेंस नहीं देख पाओगे आप, वो एंगल कितना बना रहा है वो दिखेगा. Completed writing?
Yes.
So that's all for today. Tomorrow, lecture 6 to 7, we will complete that remaining diffraction related sum and polarization one. Okay. फिर कल सब खत्म हो जाएगा. Then Sunday I will just see whether if you are free, then take one extra lecture for atoms, molecule, nuclei, synopsis to be complete by Saturday and Sunday, depending upon your availability, otherwise not. And test will be on Monday, as you are told, on full light chapter. So that's all for today. We'll meet tomorrow 6 to